Hi there. So we now know the parallel postulate, which means we can finally prove something you've probably known for a long time. So let's just jump right in here. Theorem 913 says for every triangle, the sum of the measures of the angles is 180. So you've heard this a long time ago, but we never actually used it in this class because we couldn't prove it. It needed the parallel postulate. So here's, I'll talk you through the gist of this. I won't give you a formal 2-column proof, but I will write out the key steps. So basically, we're just given this triangle. And I'm numbering the angles just so I can refer to them more easily. And what we're going to prove is that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 really is 180. And so here's the sketch of the proof. I'm going to use the parallel postulate to draw the unique line through A parallel to BC. I guess the parallel postulate is not, it's folded in a slightly different way, so I may have misspoke. But here's what we can definitely do. We know that this line exists. There is a unique line that goes through A that is parallel to line BC. So let line AX be parallel to segment BC. And I'm going to name these angles here. So I'm being a little informal, but from the picture you can see what's going on. So here's what we know. We know that the measure of angle 4 is equal to the measure of angle 2. Why is that? Well, I have parallel lines, and what we saw in the previous section is if I have parallel lines, the alternate interior angles are congruent. So that's by PAI. This one's new. AIP came earlier, PAI is relatively new. Similarly, 5 and 3 are alternate interior angles with the Z here from parallel lines. So measure of angle 3 is the same as measure of angle 5, also by PAI. We know that the measure of angle 4 plus the measure of angle 1 plus the measure of angle 5 is 180. So this is sort of a version of the angle addition postulate and the supplement postulate. We have 3 of these angles instead of 2, so formally explaining it would require a few extra steps. But I hope everyone understands that, well, angles 4 and 1 together are supplementary to 5. So measure of angle 1 plus measure of angle 4 plus measure of angle 5 would be 180. So this is sort of a combination of angle addition postulate and the supplement postulate. And now I can just make a substitution. Measure of angle 4 is the same as measure of angle 2. Measure of angle 5 is the same as the measure of angle 3. So when I make those substitutions, I have measure of angle 2, which is the same as measure of angle 4, plus measure of angle 1, plus measure of angle 3, which is the same as measure of angle 5, is equal to 180. And that's what I said I was going to prove, just in a slightly different order. So once we're able to do more with parallels and we have PAI, we finally get this fact. So you are now allowed to use this in proofs and in solving problems. Up to this point, it might be something you knew, but it wasn't really something you could legitimately use in this class. Now it's fair game. And we have a few quick corollaries once we know this. So this says, given a correspondence between 2 triangles, if 2 pairs of corresponding angles are congruent, then the third pair of corresponding angles are congruent. So here's the idea. If I have 2 triangles, and I'm only talking about congruent angles, not congruent sides here. But let's suppose here's A, B, C, and here's D, E, F. If I know that angle A is congruent to angle D, and that angle B is congruent to angle E, then I can conclude that the third angle in the first triangle and the third angle in the second triangle are also congruent. And the reason is that we could calculate it. To calculate the measure of this angle, we would take 180 minus what these two are. To calculate the measure of angle F, we would take 180 minus what these two are. But they're the same. It's the same calculation. 180 minus whatever this measure is minus whatever this measure is. So we would get the same answer. This is basically what we'll call angle-angle similarity later on. Triangles are similar if they have the same shape in terms of all their angles, but not necessarily the same size. If two angles of one triangle match two angles of another triangle, then they are similar. Another corollary here, the acute angles of a right triangle are complementary. Let's see why that's true. I don't need to give a formal proof, I'll just kind of talk through this. I know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180. But if this is a right triangle, measure of angle 1 is 90. So if I subtract that, I have that the measure of angle 2 plus the measure of angle 3 is equal to 90, and that's what it means to be complementary. And then finally, we have something like the exterior angle theorem, but much more powerful. If I have a triangle and one of its exterior angles, here's angles 1, 2, 3, and here's angle 4. So what do we know? On the one hand, we know the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180. On the other hand, we know from the supplement postulate that the measure of angle 3 plus the measure of angle 4 is equal to 180. So I could make a substitution. Both expressions are equal to 180, so they're equal to each other. And I can subtract the measure of angle 3 from each side. And when I do that, I'm left with measure of angle 1 plus measure of angle 2 equals the measure of angle 4. So what this is saying is the measure of that exterior angle is exactly what I would get if I added together the measures of these two remote interior angles. I don't feel like these corollaries need to be really learned individually. They're just examples of how once we know this fact about 180 in a triangle, we can use it to figure out a lot of other things. All right, so that's it for this relatively short section.